Hello and welcome back. My name is Corey, and you are my rubber ducks for the evening. And this is the series of episodes where we are creating a programming language, a scripting language really, a programming language called Tang from scratch. If we don't write it, it doesn't exist in our language. And we're using C++ as the language that we are writing, we're implementing the language in. And this is all using basic tools: Flex, Bison, ICU, Google Tests, a terminal window. Vim is our text editor. This is 100% live coding. I am doing it all in front of you. I say that there's nothing up my sleeves. I don't have anything pre-prepared, which means you get to see all of my mistakes and everything. And what number were we on? 91. This episode, we've been focusing on improving the speed of our language. And we realized about 2 episodes ago, in some experimenting and exploration, we found that we were spending a lot of time creating garbage collected values to the tune of millions of them. And so we've started focusing on optimizations of saying, can we avoid that? And one of the ways we can do that is by specialized opcodes. So by default, we had taken a very naive method of always creating a copy of operands for, say, a plus and putting them both on the stack. Well, that creates a copy of those and then pop them off the stack. So it's not just the fact that we're creating these values, but it's that we're manipulating a stack position as well. And so, yeah, what we're needing to do is say, in certain circumstances, we can grab the value without involving the stack. And so in the previous episode, we converted 2 opcodes to that, 2 of our binary opcodes. And by binary, I mean 2-part, as opposed to unary or ternary. So binary meaning plus, there's left-hand side and right-hand side, or minus, or divide, times, all of those, less than, equal to, all of those. We've been converting those. And so today we're going to continue that. I actually recorded a video earlier today, and then I took a break and ate supper and everything like that, and I'm like, I'm enjoying this. I'm enjoying the progress. We've actually gotten about 10% performance improvement in doing this. So I want to jump back in. Let's see. What do we normally do here? We say make clean to make sure we've got a clean commit, a clean starting place, and then make test watch, and that will compile on the right-hand side. On the left-hand side, we will say git log. Our last commit was episode 90 right there. And if I say git status, there are there's a call grind thing, but I want to keep that to be able to compare against it. But there's no code changes. So what do we want to do? Well, we need to add a few more opcodes. So that's going to be include opcodes and source opcode, and then source program. There's going to be analyze, source program dump, source program execute, and then our source AST node binary. Yeah. Are there any others? I don't know. We're just going to jump in, and we're going to try to do a lot of them. And I'm hoping that by batching them together, we will get into some, a rhythm, so to speak. And so let's see. We've got here if I just copy these and paste them, and now I say colon, so here, comma, here plus 3, substitute, subtract for add. Okay. And if I do that again, we can substitute minus for plus. Hope that'll work. We're about to find out. It worked. Okay. So the only thing is these are no longer lining up, and they need to line up, otherwise, you know, I will be sad or something. So, okay. So that's the add. Can we? Let's just continue this. So that's going to be for multiply. That's going to be for divide. That's going to be for modulo. That's going to be not negative, not, less than. Here, let's do less than or equal to, greater than or equal, equal, not equal. Are there any others? I don't think so. All right, we're going to go from there then. And put my phone on silent. So I've got add, subtract, this one, dot, comma, dot plus 3, substitute, add for multiply. And substitute plus for times. All right. Now dot comma dot plus 3, substitute add for divide, dot comma dot plus 3, substitute plus for had to escape it, I think. Okay, that worked. Remove divide, dot comma dot plus 3, substitute add for modulo, substitute plus for percent. That worked. Negative, not, we'll leave those. Dot comma dot plus 3, substitute add for LTE. Is that right? Dot plus 3, substitute plus for less than or equal to. All right. Few more. Dot comma dot plus 3, substitute add for GT. Substitute the plus for greater than. All right. GTE. got the greater than or equal to. Only got two more. And this is EQ. Substitute the plus for a double equals. All right, and one more. Substitute add for not equals. Plus 3, substitute the plus for not equals. All right, so that is all of our new ones. And now, guess what we need to do? Almost there. All right. It's going to complain now because we got rid of a lot of opcodes that it needs. And now we've got to do that here. So there. Subtract, multiply, divide, modulo, negative, skip, oh yeah, we didn't need negative. Skip negative and not. That's the less than. Here is the less than or equal, greater than or equal, equal, and not equal. All right, and now just have to do what we did just a moment ago, and that is plus 3, substitute, subtract for add. There we go. We're going to substitute, subtract for multiply. All right. Substitute, subtract for divide. Substitute, subtract for modulo. All right. This will subtract for LTE. No LTE less than or equal to. Do it again. Now it's greater than. Now it is greater than or equal to. Now it is equal. And now it is not equal. And do I have all of them in place? The answer is yes, I do. All right. Now, what is this? Dump bytecode. Ooh. Let's see what we did for subtract. Oh, so we did the sorry, my brain's, we did this. Did we do dump program check? Oh yeah, dump program check will. Oh no, we're in analyze, not. Look at this. I just had the wrong description up there. I'm like, what's the deal with this? What's happening? Oh, I don't know. Anyway, all right. Let's go back to subtract. Highlight all of those because we need to have it for add. Multiply. Nope. Divide. Modulo. Do we need it for negative? No. Not. No. Already got it for less than. Need it for less than or equal to. Greater than. Greater than or equal to. Equal. And not equal, right? Yep. Anything else there? No. We got it for modulo? Got it for divide? I guess we got it for all of them. So there's the add. And now what we need to do is we need to dot comma dot plus, how many is this? 18. Substitute subtract for add. All right, and now search for case. So D3. This one is multiply. This one is divide. This one is modulo. This one is LTE. This one is greater than. This one is greater than or equal to. This one is equal. And this one should be not equal. All right, I think I've got all the unused ones gone. All right, so next, the dump bytecode. This is going to be largely the same. So there it will be for add. Here will be for multiply. Divide. Modulo. Don't need it for negative, don't need it for not. Already have it for less than. Here's less than or equal to. Greater than or equal to. Equal. And not equal. And there we go, got that one cleared up. This one is equal. Yeah, I'm working backwards now. Uh-oh. No, I can do that, but instead of 18, it should only be 15. There. That's safer. And now this one is greater than or equal to. This one is greater than. This one is less than or equal to. This one is, oh, modulo. This one is divide. Okay, this one is multiply. Sorry, I have to think of what keys I'm hitting. So this is the real subtract. This is add. All right. So the dump should be working. Is this the program execute? Yeah. Okay. This is going to be 19. Yeah. Look for case in this case. Multiply 4, 5. Divide 2, 3, 4, 5. Modulo. Not negative, not. The less than we already have. Less than or equal to. Greater than. Greater than or equal to. Equal. Not equal. That should be all of them. Yep. And now we'll do the subtract. Yeah, and now we're at the not equal. Is this 15? No, a little further. Well, 15 will catch him. But if I instead say 20, well, no, it takes me down to the last line. That's all right. Equal. All right, greater than or equal to. This is going a lot faster than I thought. You say, Corey, this is rather boring. I know. We don't have the compilation one. That's going to be the hard one. This is the greater than one. This is the less than or equal. Modulo. This is the subtract. Not subtract. This subtract is highlighted. This is divide. There we go. This is multiply. This is the real subtract. And then this is add. All right. That should be everything under the execute. So we've got the up. Are we down to the last file? Yeah. So we've got this kind of helper for the binary op thing. We're going to kind of have to do this again. Equal, not equal. Okay, so the and or are going to require special attention. We'll get there. First of all, I'm going to switch out subtract for add on that line only. That's fine. Going to do it here, but for multiply that line only. Do it here for divide that line only. Here for modulo that line only. Here for less than. Oh, I already had it. Here for less than or equal to. Here for greater than. Here for greater than or equal to. Here for equal. Here for not equal. There. Now the only thing is the left-hand side, right-hand side, all that stuff. So we need to there. Compile those two, and now we can get rid of that. We can get rid of these two, and we can get rid of these because this is a standard binary operator. See what happens. Now we use a lot of macros, so hopefully everything is just going to work. That would be really nice. Looks like we got through the analyze, the dump, the execute. Okay, some stuff failed. Oh, and we have something taking off. Well, there's no way it was going to just work, was it? Okay, so before we get into this too far, so we've got the add is add, subtract is subtract, multiply is multiply, divide is divide, modulo is modulo, less than is LT, less than equal LTE, greater than is GT, greater than or equal GTE, equal is EQ, not equal NEQ, all right, so all of this looks correct. We just don't know what's happening. So I went ahead and paused this right behind me, or killed it. What I want to see is the get diff. What did I miss, if anything? Well, before I do that, might as well just say make clean, make test, and this is just to, you know, do a fresh copy just in case we've missed something, which sometimes happens. Nope, it is indeed. All right, so now let's check out the diff. So for our opcodes, we have add. We replace multiply divide modulo with multiply divide modulo. Less than, greater than equal to, not equal, equal, not equal. Less than or equal to, greater than or equal to, equal, not equal. Okay, that all looks correct. For the compile, now what did we remove? We said if this op is equal to so let's see here. Add, multiply, divide, modulo. Had we already done the less than? Yes, we had. Less than or equal is LTE, greater than GT, greater than or equal to GTE, equal EQ, not equal NEQ. And then for the and, we had to add the left-hand side, compile. And then it does its own right-hand side, compile, based on, whatever. Now, we are not optimizing this at the moment. So the and the or is going to still copy always. Okay, so that all looks correct. What else did we change? Okay, that's fine. Multiply, divide, modulo. 3, 4, 5. We took out 5 and added 5 groups. That all looks fine, or looks correct. Same order. SE, add SI, add IS, add II. Multiply SS. Then modulo. Less than or equal to. Greater than. Greater than or equal to. Equal. This all looks correct. Not equal. And now in the dump, which we're not calling that, so I doubt there would be a problem here, but we got the add, we got the multiply, the divide, the modulo, less than or equal to, greater than or equal to, equal, and not equal. And then the execute. SSSI, ISII. Okay. Oh, yeah. Look at that. You see it? The execute. Did I really do that? Okay, now all that we need to do is, well, dot, comma, dot plus 18. And what are we substituting? We're substituting the minus for a plus. There we go. We'll do the same thing here, except we will substitute the minus for a multiply. All right, we'll do the same thing here, except we'll substitute it for a divide. Do the same thing here. except we'll substitute it for a modulo. Same thing, except here it's less than or equal to. Here, except it's greater than. Here, greater than or equal to. Here, a double equal. And here, it's a not equal. All right. Let's see this again, shall we? Oops. Figured it was a copy-paste error. So we're only 40 minutes in. So that's actually making really good time. All tests are passing. Yes. All right. So I'm just thinking at the moment. I want to make sure. Add SI opcodes for. What all did we do? Add. We had already done subtract. Multiply. Divide. Modulo. We'd already done less than. So less than or equal to. Greater than or equal to. What else? Equals and not equals. EQ and NEQ. There we go. Okay. Now I'm wondering, do we leave well enough alone? Or do we... And by the way, this is not going to really make a change. If we do time... build apps Tang -s and feed in fib.tang. It's not going to really change this time. Maybe I'm wrong. Because we dropped down to sub 7. So this is with the rest of binary operators. Okay. This is with only minus, and less than. Okay, I don't remember. But this was original, right? Before optimizations. And what all optimizations have we done? Well, that's what git log is for, right? Okay, so we just did the bottom one. Before that, we did subtract and less than. Before that, it was call func, right? And before that, was that just after optimizations? I may have to go back and look at the video. I don't think so. Something seems... I don't know. I don't remember. I was going to say after bytecode optimizations. I don't know. But this, I'm impressed with. I didn't think it would make a difference there, but evidently it does. All right, let's see what else. Yeah, it's hovering right around that point. All right, yay. So what I was going to check on is the... If I open this up again with the Vim, but instead of well, I'll leave binary, AST node UNARY. Why? Because UNARY is the negative and not. And for this, we just compile the, compile the operand and then just choose. So now we could have a negative S and a negative I, and a not S and not I. Do we have enough time? Maybe. Shall we try it? Sure, why not? So what will this look like? Well, we've got a negative and a not, and we need a negative S and a negative I, just like we have a not, or we will have a not S and a not I. So the push the logical not of a val. Yeah, oh wow, we could do this same thing basically with the cast. Wow, there's so many. By the way, if we just look to see how many we've got, we're starting on line 24. And, well, there's a couple blank lines in there, but 112. So we've got around 80 opcodes. All right. So negative S, negative I, not S, not I. Okay. Negative and not. Where are you? All right. All right, so in the case of the negative I, it needs to be PC plus equals 2, right? Because we have to have there. Now, what's funny is we can just call dump binary I. Oh, wait. All right. What else? So dump binary for that, and dump binary I for negative I and not I, and then that looks right. Okay, the execute. So if we look at binary op SI, so we're going to have binary op S and just call this stack check 1. It's not binary, it's UNARY. Operand is equal to stack back, pop back. That's fine. But if it's I, execute program check, we don't need a stack check. Well, we can just say the index is that. Index. Operand is that. Forget that. Forget that. And plus equals 2. Okay. So negative and not now are going to be negative s, negative I, not s, and not I. Okay. And then it's going to be UNARY op s, okay. Same way for not s. And UNARY op I, UNARY op I. Okay. So in the execute, what? Oh, this is AST node binary. That's why. I was like, what's going on? I'm lost. We will definitely need AST node identifier. And in the compile, this is where the interesting part will be. So it's going to be like kind of like this, but not really. Huh. We just need to know but instead it will be negative s and negative, whoops, I, whoops, and also UNARY. No, 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 no. I did it. Change add into negative S, I, and that's it. And now change negative into not there. All right. Now we just need to do something with it. We don't even need to call that. We just need what our UNARY op thing is. We can do that by, oh boy, how long is this? Oh, we can get this. To be honest, this is really bothering me, how it's not indented, as I normally do. So UNARY op s, op I, and that is it. Okay, so colon from here to here plus 40, change LHS index into just regular index. Whoops, let's try that again. All right, so identifiers program.get identifiers, that's fine. Is it operand? I'm old and forgetful, I don't remember. Operand, that is right. So here to here plus 40, anywhere where you see LHS, change that to operand. All right, so if the operand is an identifier, the name is that. If there's a count, okay, do that. Op I index compile the operand, don't need right hand side. Op S. Yeah, that's it. We'll see if that works. Because that was like just a quick 20-minute little thing. Oh, of course not. Binary op SI. What? Program execute. UNARY op? UNARY op. This should, oh. Oops. Okay. That's better. 63. Oh, no, wait. That should have been index. Okay. Any other silly little mistakes? Uh-oh, don't want to fall through. 613. What happened to my break? Passed all the tests. That is good. And you know what? I'm always curious. So the negative s and negative I just want to see out a 1 versus the, well, just a quick little sanity check to say, is this using it? If you have a nice mixture of 1s, 2s, 3s, and 4s, that'll be cool. A lot of 1s, which are negative from the stack. Okay. No negatives with an index. Like, I never have a negative A. Huh. And when I wrote the UNARY negative, I probably didn't have variables yet. That may be the reason why. But 3s and 4s, so those are compiling. So, all right. And let's see, negative and not. Oh, I need to include in the makefile the AST node identifier for the UNARY. Okay. Before I forget, where is it defined? Oh, it's defined way up there. Good. Okay. Yeah, we're good there. As usual, we want to and this one, thankfully, was quite straightforward, I think. What wording did I use? Add SI opcodes. Okay. For negative and not. All right. Did I need to do anything else? That is, I was trying to think, did I change any documentation? It's easier to just run it, update it. We'll be good. While that's running, what number are we on? Number 91. I always forget. Yeah, there were some changes. episode 91. Push all that up and add our tag for episode 91. All right. One of the last things we do, we're over the 12,000 line mark. We have a substantial number of our opcodes though now with these optimized forms, and we can continue. We can extend that, right? And we could with the print, right? Because print. Oh my goodness, print is all over the place. Yeah, that one would definitely benefit from having that form. So we can do it with print. We can definitely do it with all the casts. As Boolean or as whatever. And we haven't done our ands and ors yet. That's the only thing. So, yeah, we'll have to worry about that. But, you know what? We're ending up at a good place and made some good progress. Again, thank you for joining me on the journey, and I hope you're enjoying it. Thank you, and have a great day.